All right, welcome everyone. This one's a true honor to introduce. I get to introduce my colleagues at the Wisconsin Department of Transportation. They're here to talk about AWS and ArcGIS Image Dedicated. I saw these guys see this effort through firsthand, so I'm pretty excited about this. Today we got Tony Vanderwellen and Ben Hostetler. They will be explaining why WisDOT chose to transition to a single storage solution for the imagery and LiDAR with Amazon Web Services and Esri. They'll go into the details of the technical implementation of the solution. Take it away, guys.
All right, thank you very much, Joe. So I'm going to talk a little bit about AWS and ArcGIS Image Dedicated at WisDOT. Again, this is Ben Hostetler, and we are very happy to be here to talk about this. So this was an IT project that we did through BITS, our Bureau of Information Technology, to kind of transition and consolidate all of our imagery and LiDAR into one storage location. We had very disparate locations of all of our storage of imagery throughout DOT, and this was that effort to kind of consolidate everything into like one technology. Just give you a little bit idea of what it looks like at DOT. We have approximately 300 plus desktop users for ArcGIS Pro and desktop licenses. We have an enterprise portal with approximately 15 to 1,600 users of that enterprise portal. ArcGIS Online, about 300 some users, and then we have a lot of civil 3D implementations with our engineers who are working on the roadways. We wanted to create that mechanism for sharing imagery with state agencies, and we also wanted to create a mechanism for imagery uploads from our partners. So we didn't want to carry around the portable hard drives anymore with terabytes of storage and have it locked away in closets for years and years and years. So we wanted to get that imagery out to everybody. And then potentially cost savings. That wasn't the driving factor for the project, but it was a big factor in the project, and I'll show you some of the costs associated with that. So just a few of the technology terms I'm going to use today. ArcGIS Image Dedicated. If you're familiar with ArcGIS Server, this is an ArcGIS server in the cloud. So it's a SaaS offering, software as a service. So it's no longer on our local server kind of farm in our data center. This is up in the cloud. And they did have this up into the Amazon cloud, so our compute is very close to our data at this point in time. Amazon Web Services, I'm sure you're familiar with at least Amazon. It's infrastructure in the cloud, so it's all the servers and storage space. AWS Lambda. Lambda is serverless code, so it's when we store things in Amazon, we have code that's triggered, and when the code is triggered, it converts the imagery that we're putting up there into a more cloud-optimized format. So, and then distributed collaborations, we're using a distributed collaboration with our ArcGIS Online organization to get base maps and imagery over to our internal portal. So some of the imagery that we have, those are some of the terms that we're using currently. The initial project overview, this is kind of what it looked like when we started out. So we have WisDOT represented down below. We have a survey and mapping unit, and then we have a GIS unit. We have GIS infrastructure kind of in-house. We wanted to store all that imagery in Amazon and then convert that with Lambda to a cloud-optimized format, put that in ArcGIS Image Dedicated, that server space, and allow those REST endpoints or those access points for imagery to be exposed. So we also did that with our internal servers too, so we could do some testing initially on the project. So we stored all that imagery in the Amazon cloud, and then we made services locally too for our own testing purposes as well. So finding the optimal server solution, that was kind of the big portion of this project. We wanted to make sure that moving all this data into the cloud was the right thing to do. We already had a pretty big infrastructure footprint at DOT through DET, and going to this solution, we wanted to make sure, one, it was going to be efficient enough to do it, and that we could just do it. So we did a lot of testing with our current environment. Like I said, we replicated a lot of things, so had the same kind of data locally on local stores and on our local servers. We did lots of testing there. We did a hybrid approach where we put the data out in Amazon, and then we test it with our current server structure. And then we did a full cloud implementation and tested that as well. This is what it kind of looks like, and I can't take credit for this at all. Ben did all the testing. So we tested every single stack with about 3 or 4 different types of image services, and we did that testing on an average. So Ben would run these things 4, 5, 6 times, 10-minute test cycles, and then we would average all the results together to get the results so that we were making sure that we were making the right solution to go into the cloud. So this was a little bit of work. A little bit, yeah. Yeah. Some findings that we got from that testing is that on the Advantage side, there was no longer maintaining. We currently have 2 to 4 image servers that are currently located for DOT staff to utilize imagery from. We wouldn't have to utilize those anymore. Our current servers don't scale very easily. We have to call DET, wait a couple months, and then they eventually would, give us more RAM or CPU. There's no infrastructure to upgrade in the cloud, and really it's best practice for us to be having our data and CPU compute right next to each other. So on the downside, initial speeds from our testing, all that testing that Ben did, initially wasn't faster. So our current implementation was probably a little bit faster, but not enough when we look at some other factors that go into this. We don't have any more granular control of the services. If you use ArcGIS Server, you know there's a lot of options for you with your services. When we're using software as a service, it's kind of like using ArcGIS Online. You can have a hosted feature service in ArcGIS Online, but you don't get to control a lot of the kind of technical things associated with that service. So we wouldn't have that control anymore. And then we had disconnected editing workflows that we no longer could utilize with our base maps if we put them in Amazon. And then support. Who has heard of ArcGIS Image Dedicated before? Anybody? We have 1 person? Okay. Fairly new offering from Esri. 2, 3. Those are all my team members. Thank you. Support was a thing that we had to figure out. So they had a small team too at Esri. We wanted to make sure that if we are going to implement something and deploy it to 3,600 employees at DOT and potentially the public, that if something went down, we would have the support, or if there was scaling that needed to happen, it was going to occur. This is kind of what it looks like in the end here. You can see not much has changed, but we have fully implemented this. So currently we have about 115 terabyte of storage in Amazon for imagery. We've converted that raw imagery into cloud optimized formats. We're utilizing the ArcGIS Image Dedicated server in the cloud, and we have hosted image services currently out there for imagery. We feed those services back into our infrastructure, so we're coming from the outside in, and then we also have that feeding our ArcGIS Online kind of instances as well. And public client access, we'll talk a little bit about that later, but just to preview, all these services for imagery that we have out there are public. So, state agency access was a big thing for us to consider in this project. And this is kind of the model that they can use. We have source imagery that we utilize that state agencies can access through Amazon with their Amazon accounts, which are free. And we also are able to kind of clear the path for other state agencies to get those accounts through this project. And that took a long time. Probably just to create a bucket and get an account in Amazon took longer than the whole project that we did to get the data up there. So we also have that optimized imagery bucket. State agencies can connect to either one of these buckets, read-only, and pull that data over into their own Amazon bucket and then utilize those things, or they can use read-only access directly from our buckets. So it's pretty efficient. If you look at the costs here, so for us to store 116 terabyte of data at the DET storage centers, we're looking at about $375,000 a year to store it. Through Amazon, we're looking at about $30,000 to do that. So there's substantial cost savings here as well. And again, that wasn't the drive of the project, but it's pretty nice. So I will mention, though, to take that imagery out, if you were to pull it down to your desktop, there are egress charges. It's kind of like taking data out of the data center. So for every terabyte of data you take out, it's approximately $90 from Amazon. So if you were to download a terabyte of data to your desktop, they would charge you some money to take that out. But we're hoping nobody has desktops big enough for 100 and some terabyte of storage, though. So how has this changed everything that we're doing as far as imagery goes? We had a lot of imagery stored on servers all over the place. We had some map services available, but they were small, and they were for very small areas. We've gone to a more service-based approach. This service-based approach is utilizing imagery from the same location in every single platform at DOT. So now you can access the same imagery from ArcGIS Pro, Civil 3D, GeoPortal, ArcGIS Online, custom applications, and also public access. And the great thing about this is that because DOT is so big, you have engineers and GIS people in business areas all looking at data, and now it's all the same data, which is really cool. Costs associated with this too, if you're looking at just the server costs that we had, just on the storage side alone, we're saving approximately $40,000 a year on storage costs for the servers. So there's also substantial costs there for licensing and servers. I'm actually going to hand this to Ben so I can show a little demonstration. What time? Are we good? Okay, we're good. Maybe I do need to do this. Okay. So Civil 3D is a big thing for us at DOT. We have a lot of engineers. Oh, yeah, you can see it on the screen. We have a lot of engineers that need imagery for the project work that they're doing. And this is an example of how they can utilize the REST endpoints from our imagery services that we're currently putting out through this Image Dedicated product and sourced in AWS. This is the REST endpoint. I'm going to kind of fast forward a little bit here. This is an example of someone going in, looking at doing work on this particular area of the state. And you can see there's a bounding box here that they're kind of working with. And as we kind of fast forward through it here, you're going to see the Civil 3D user is going to start pulling images from our image server. Now these are very small files. It's just making small requests to the image server, pulling the images down to the box. And then our Civil 3D developer who's working on this stuff actually takes all those small images that are in a temporary space and he mosaics them together. So what you get is a seamless image of the actual project area that they're working on. And because it's mosaic together, you can see the very small file sizes that we're talking about. Because it's mosaic together, they can actually make one file out of this, which again is fairly small. Kind of fast forward this a little bit. And then within Civil 3D, you can actually see the actual markings of the intersections, and the Civil 3D work that they're doing is overlaid against the imagery here. And this is that, in this case, I believe it's 6-inch imagery from the county, from the WROC program. So you can see the drawings in the background and the imagery. The great part about this is when you pull that imagery and you mosaic and you put it in Civil 3D, that imagery stays with that project forever. And when they come back out and do another Civil 3D project, they're pulling the data from the service, which is the most recent. So they have kind of the history of the project, and they also have the new imagery as well. All right, so that's the portion I have. Ben is going to talk a little bit more about the workflows that we had to do to get this working. So he's going to explain this system diagram, so I'll turn it over to Ben.
Thank you, Tony. And most of you can tell that our upper leadership was pretty convinced that we should move forward with this, with cost savings, not a big impact on performance. So yeah, I'm going to dive into some of the implementation here, and Tony touched on some of it, but I put together this diagram after the project actually just to provide an understanding of what happened. So this wasn't really before, this is kind of after, and I don't know, can you guys read any of it in the back by chance? Okay, I used colors and shapes for that purpose. So we're gonna start in the upper left corner, and I'm gonna just walk through moving from raw imagery, how it got to services and out to our platforms. And up in the top left, it says upload data. And in this case, we were doing it from the drives that were getting passed around. And finally, we put all the data from drives into our S3 source bucket. And S3 in AWS stands for Simple Storage Solution or Simple Storage Service. And it's scalable. It's object-based storage, not file-based. So a little different concept. And in object-based storage, things move really fast. So when you're moving tile caches and things like that, you're moving hundreds of gigabytes in minutes, possibly. Anywho, that's kind of the start in the upper left. That blue square is where a lot of the raw imagery is sitting. And you'll notice green diamonds, and all the green diamonds are points of consumption. And one of the most basic points of consumption is downloading with WinSCP. This was an ask from an end user that they just wanted the non-optimized imagery for project work, and this was a easy solution. They could download many files at once or many TIFFs, the GeoTIFFs, and that's all they needed. But moving forward onto the yellow gear there, that's the AWS Lambda, and that moves on a triggered event. So when data hits the source bucket, it gets optimized. And that's happening with a little app, a JavaScript app, that is actually changing the compression type on the GeoTIFFs one by one. It's an automated process, and it scoots it over to the top right blue square, which is your destination bucket. Here we have a cloud-optimized GeoTIFF. And during this process, unfortunately, we found out that we lost our projection information for county coordinates because GDAL is a part of the Lambda process, and it didn't know the unique Wisconsin county coordinates. So we had to reintroduce those from a Python script on all of our county imagery to hit in the destination bucket there. So when that is all done, we have good cloud-optimized GeoTIFFs that have their projection, everything's lining up, and at that point, end users can consume those in ArcGIS Pro. Another point of consumption in the top right, that green diamond, users can just pick individual cloud-optimized GeoTIFFs. And moving forward down to this spot with the red box, that's a point of configuring in a local environment. And this, I put a red box because this was kind of a pain point and a lot goes on here. So here we assemble each county, like a mosaic data set for each county, and we call basically all the images in the destination bucket and put it in a mosaic data set, and then write out an image definition file. And that image definition file is used to publish the service. With that in place, you are now publishing REST services, and you have your image services. I'll show in a little bit the variety. I'm talking a lot about the county-based imagery, but we also have cache tiles too, and we'll go through that in a little bit. But moving on with the REST endpoints, so once we have the REST services published, we can add those into ArcGIS Online. your bottom left. And then Tony mentioned the distributed collaboration occurring with the groups. And as we add these services to ArcGIS Online, it is basically synced and replicated in our enterprise portal in 3 different groups for 3 different environments at WisDOT: system test, acceptance, production. And once this is all set up and it's working, 2 points of automation, next, future years of pumping imagery into this, a lot doesn't change. The imagery can just get uploaded. It's gonna be triggered to be optimized, and really we just come back and do some reconfiguration and update to say, hey, grab the 2025 data instead of the 2023 data. And then everything else that's already in the works, end users will not even notice the difference that there's new imagery. It's fabulous. Really looking forward to that now that it's built. But yeah, I will probably go into a little demo here.
Yeah. Okay. We do that. Can you get in there? All right, so we'll probably show a little bit of demonstration of what it looks like. So this is a REST endpoint from the ArcGIS Image Dedicated. And as you can see, there's a couple different areas here that we're going to talk about. The base maps, we moved all our base map imagery over to Amazon. So these are all cache tiles, and they work with the ArcGIS Image Dedicated server. And so we can put all this data out here, which is just terabytes of data, and we can stream it to all of our devices, like our ArcGIS Pro, our ArcGIS Enterprise Portal, and ArcGIS Online, all at the same time. So again, Ben is going to show the county services now. These are all the WROC services that we've created through ArcGIS Image Dedicated. Again, we had the raw imagery, we converted it to optimized. Ben did a lot of configuration there, and then we have these services that are out. These are dynamic 3 and 6 inch services from WROC 2020 and some from 2023. And then here's the statewide folder. Here's all of our kind of our base map tile caches that were utilized here, and also some dynamic imagery from the past from NAPE and also WROC. The cool thing about this imagery in that statewide folder is there are cached tiles here. So statewide 12-inch cached WROC imagery and NAPE imagery that can be utilized publicly. So if you want to go out here, you can explore and take a look. The rest of URLs are open, and again, we're using this for Civil 3D. We're using it for all of our platforms. So I highly encourage you to go out there and take a look and see what you can utilize. This is an example of ArcGIS Pro. So with ArcGIS Pro, you can create what's called a ACS file or a cloud connection file. It's really easily configured within, it's kind of like creating a database connection within ArcGIS Pro. Once you configure that to the Amazon bucket, you can get information in here, like our cloud optimized geotiffs. You can pull it right into ArcGIS Pro. And when you do that, those individual geotiffs, you can do analysis on them. You can do clips, and you can do buffers, and you can do a lot of information that you could do from a local imagery source that you have on your machine. But it's in the cloud. Everything is there. And when you do that analysis, those file types are saved locally, so you don't have to worry about pushing everything back up to the cloud. And hopefully I'm following what Ben's showing on the screen. Any questions while we get going on this? I know we only have a few more minutes, but yep, over here.
Does the dedicated image server consume credits like ArcGIS Online, or is there a separate, like a fee for that?
Yeah, sort of. It does. Yeah. Yes, it does. There's a cost for Image Dedicated. There's a set price that you pay, and within that set price, they actually have a buffer for credit consumption, or it's not really credit consumption. It's actually egress charges, because you have that image server in AWS and you have the data right next to it and you're pulling data over between and then you're pushing out data through the REST endpoints. And that little bit of egress charge that comes from consuming from the REST endpoints, that's kind of built into the cost of ArcGIS Image Dedicated. So does that make sense? Okay. All right, cool. He's showing a clip now. How easy it is. Does this make sense? Is this?
Yeah, we're flipping data off the REST endpoint.
Yeah.
Easy as that. Bring in from the REST endpoint.
So hopefully we're not disrupting too many workflows at WisDOT 2. Our goal was not to change everybody's workflow. We wanted to make it easier, and we wanted to make sure that the imagery that everybody was using, from ArcGIS Pro to Civil 3D to the platforms that we're utilizing like the portal and ArcGIS Online, were all the same. So instead of getting imagery from certain locations, there is still a need. This doesn't cover everybody within DOT. There is still need for other types of imagery that has to occur, more of a customized solution or a kind of a real specific need, but in general, it seems to cover a lot of the needs of DOT. But, yep.
Yeah, Tony, so you alluded to the drivers of this project, and that cost wasn't the primary driver. So what was the primary driver? Maybe I missed it.
So we had tons of imagery all over the place. You've got engineers maybe getting something from Google, getting it from our other survey and mapping unit. You maybe had them pulling imagery from some other place. Could be historic, could be just wherever, taking it from Wisconsin View or getting it from a county.
Yeah.
Now all that is centralized into one location where we have that. We have the raw imagery, we have the optimized imagery, we have the services coming all out of the same spot. So that was really the idea of the project, to try to get it all together.
Yeah, okay, that makes perfect sense. I'm wondering, did you have a kind of a campaign to message this out so people knew, hey, there's this one-stop shop, and stop going into various rabbit holes for your imagery?
Yeah, there was a huge communication plan associated with the project. So our Office of Public Communication would send out notifications that the team would provide for this. Our Civil 3D users are working closely with the Civil 3D the developers who push out the products, to make them aware that they can get this imagery streamed right in. And then our GIS unit at DOT, we also have something called GTAC, where it's a monthly meeting of all the GIS users. We try to get as much information out to them as we can. So DOT is pretty well informed on kind of the changes that have occurred, but really, there's really no way for us to kind of tell the public that these services are now out there and you can utilize them. And so that's why we're here. We're trying to bring a little bit more awareness to that.
One more question, if
Sure.
you'd indulge me. So you're an early adopter of this. Would you recommend somebody waiting a little bit, or were there any kind of like pain points that?
Well, yeah, I think we've gotten all the gray hairs from this. So I think we're probably at this point recommend that if you have, a ton of imagery that you need to get out and you need to store it in one location. Again, DET and DOT would never allow us to have 115 terabyte of storage. Amazon is a unique situation where the cost meets the need, and we have the ability to provide the service then. Otherwise, this service doesn't happen. So that's really, yeah, I think it would be. The engineers love it through Civil 3D, because the Civil 3D engineers can actually bring in the data, and now they're starting to utilize it. And for WROC, as you know, we've got about 59 counties of 3-inch, 6-inch imagery, and the rest of the state was flown at a 12-inch. So we were actually going back to Ayers and Associates and have them reproject those 12-inch counties into the WisCors 11, is it 2011? WisCors 2011. So that we can get those other counties at 12-inch into the Civil 3D world again, and provide the rest of the services, so it would be more of a statewide representation of not just 59 counties.
As well, and that's been kind of a seamless thing behind the scenes that the users don't even know it. We changed some of the base maps, we updated them, so that's helped as well. And it's been kind of seamless for some of them that might not just download the imagery, but they're using the base maps all the time. So, and we tried to make it as seamless as possible on the project as And informing people, you know, you can't use this, you can use that.
Yeah, it's been a this is a shift. This is a change, like who moved my cheese type thing, where we don't have imagery on file storage anymore. We are going through that communication plan right now to remove access and then to delete that imagery, because once we delete that imagery on the file storage, we're saving thousands of dollars a year for storage costs. So we're trying to move those workflows a little bit, but also we tried to make sure that you still have access through Pro, that you still have access through the platforms, and there's ways of getting the individual tiles if you need them. So yeah, there's a lot of change going on, but yeah. No. Yeah. Yeah. It does, the ACS connection, those cloud connections in ArcGIS Desktop do work on the ArcMap side for some specific tools, but not in general. You can't just add it as a connection like you do a database. So, yeah.
I think Tony's signing autographs after the session here.
This is great.
I think we're good.
All right.
I didn't public speak
Yeah.
for 13 years, so I'm up here.
So just to mention that really quickly, because I kind of want to get this on the recording. Yes. So we have a giant work plan for this project. It was over a year long, and it had pages and pages of Excel spreadsheets and thing. And the last task was Ben to do a presentation at WLA on March 1st. So we can now check it off.
Good job, guys.